Welcome to the DIY Honda Garage channel. In this presentation, we will discuss the diagnostic trouble codes P2245 and P2249, which indicate low voltage in the V-cent circuit for the rear and front air-fuel sensors found in specific Honda Accord models from 2008 to 2012. These DTCs can affect the vehicle's emissions and engine performance by providing inaccurate readings to the engine control module, ECM. The affected sensors include the rear air-fuel sensor positioned in exhaust bank 1 and the front air-fuel sensor located in exhaust bank 2. Both sensors play a critical role in maintaining the engine's performance by ensuring the correct air-fuel ratio for combustion. Diagnosing these issues early is crucial to maintain vehicle efficiency and compliance with environmental regulations. The P2245 code relates to the rear air-fuel sensor, specifically the first sensor in bank 1, indicating that the V-cent circuit is experiencing low voltage. In contrast, the P2249 code pertains to the front air-fuel sensor in bank 2, also signaling the same low voltage issue in its V-cent circuit. These sensors are critical components tasked with measuring the air-fuel mixture in the exhaust, which helps the ECM optimize engine performance and emissions. The rear air-fuel sensor is typically located further down the exhaust system, while the front sensor is positioned closer to the engine. Both sensors contribute to the feedback loop that allows the engine to adjust its operating conditions for better efficiency and lower emissions. The possible causes of DTC P2245 and P2249 primarily include wiring issues, which can cause the signal to the ECM to fail to properly read the voltage levels necessary for optimal sensor operation. A faulty air-fuel sensor can also trigger these DTCs. Over time, sensors can wear out or become contaminated, leading to inaccurate readings. Furthermore, a malfunction in the engine control module, ECM, or powertrain control module, PCM, can exacerbate the issue by failing to interpret or process signals correctly. Each of these factors can lead to reduced engine efficiency, poor fuel economy, and increased emissions, highlighting the importance of thorough troubleshooting and repair. When dealing with DTC P2245 and P2249, you may notice several symptoms that signify a problem with the air-fuel sensors. Poor engine performance can manifest as rough idling, engine stalling, or difficulty accelerating, all of which can significantly impact the driving experience. Additionally, increased emissions may be observed, as faulty air-fuel sensor readings can lead to an incorrect fuel mixture, thereby causing the vehicle to fail emissions tests. The most apparent symptom is likely the illumination of the check engine light or malfunction indicator lamp on the dashboard, alerting the driver to a potential issue that requires immediate attention. Ignoring these signs can lead to more severe engine problems and higher repair costs. The first troubleshooting step involves turning the ignition switch to the on position, denoted as 2, to power the electrical systems of the vehicle without starting the engine. Following this, the diagnostic handheld system, HDS, should be used to clear any existing diagnostic trouble codes. After clearing, start the engine and hold the engine speed at 3,000 revolutions per minute, RPM, without the load, which involves putting an automatic transmission in park or neutral for manual transmission. This operation is crucial for creating sufficient exhaust flow to activate the radiator fan, indicating that the system is running properly. After a few moments of maintaining this speed, the next step is to let the engine idle for approximately 2 minutes to gather data for the system to process. In the second troubleshooting step, utilize the HDS to check for any pending or confirmed DTCs after the previous step has been executed. This inspection helps diagnose if DTC P2245 and/or P2249 are still illuminated. The presence of these DTCs indicates that there is a persistent issue in the air-fuel sensor circuit that needs addressing. If neither code appears, it suggests that the issue may have been intermittent, meaning the system appears to be operating correctly at that moment. It is advisable to further investigate potential problems such as poor electrical connections, damaged wiring, or loose terminals at the air-fuel sensors and the ECM to prevent future occurrences. For this step, the ignition switch needs to be turned to lock position, marked as 0, ensuring that the electrical systems are completely powered down. This is crucial for safety and preventing any electrical shorts while performing diagnostic work. The next action is to jump the short circuit SCS line using the HDS, which helps to set up the diagnostic environment for checking continuity and resistance levels within the sensors and connections. Following this, it is essential to disconnect the air-fuel sensor, identified as Sensor 1, located in Bank 1, to physically inspect and diagnose the sensor's integrity. This disconnection is a key task in isolating the fault within the air-fuel sensor circuit. In this troubleshooting step, the next critical action is to disconnect the ECM-PCM connector B, which serves as the central processing unit for various engine control functions. It is crucial to identify the right connector among several to avoid potential misdiagnosis. The following task involves checking for continuity between the specified ECM-PCM terminal, B15 for 2008 to 2009 models, and B24 for 2010 to 2012 models, and body ground. This continuity test is essential for confirming that the electrical path for the VCNT circuit is intact and functioning correctly. Proper grounding is necessary for the sensors to operate. Poor connections can lead to low voltage readings and erroneous DTCs. If continuity fails, further inspections of the wiring and connectors should be initiated. After completing the troubleshooting steps, it is vital to perform a final repair verification process using the HDS to check for any remaining codes. Clearing DTCs, running the system through its operational parameters, and then inspecting for any reappearance of P2245 or P2249 is crucial in confirming that the issue has been resolved. This step will help ensure that the repairs made have corrected the underlying faults in the air-fuel sensor circuits. It's equally important to re-examine all associated wiring and connectors that may have been addressed during the diagnostics to ensure proper installation and secure connections. Documenting the outcome of these checks will assist in future diagnostics and record keeping. To prevent future occurrences of DTC P2245 and P2249, engaging in routine preventive maintenance is essential. Regular inspections of the air-fuel sensors can help detect early signs of wear or degradation. Checking electrical connections for looseness or corrosion is also crucial in maintaining effective communication between the sensors and the ECM. Keeping an eye on the overall engine performance can provide valuable insights into whether the air-fuel mixture is correct, which can forewarn you of possible sensor issues. Regular oil changes and fuel system cleanings can also prolong the lifespan of the sensors by ensuring that contaminants do not compromise their functionality. This proactive approach is key to optimizing engine performance and emissions. In summary, the diagnostic trouble codes P2245 and P2249 signify low voltage issues in the VCENT circuits of the rear and front air-fuel sensors, which are essential for optimal engine performance and emissions control. Understanding the vital roles of these sensors helps in addressing potential performance issues before they escalate. Following a structured troubleshooting approach allows for efficient problem resolution and can lead to significant improvements in the vehicle's operation. Preventive maintenance is equally critical, ensuring the longevity and functionality of these components. By monitoring the health of the air-fuel sensors and associated electrical connections, drivers can maintain better vehicle performance while adhering to necessary emissions regulations. Please like and subscribe to the channel. See you next time.